least it's not raining right now. Looking a little sunnier. So, how did the homework go? Yeah. Well, I mean, what you did, how did it go? Oh, these aren't positive sounds.
Starting to get ahead of it?
Yeah.
Do you need some examples done, or they just are taking a while to do?
It's usually takes a while. Sometimes I don't understand, like, you have to multiply it by g, but then if you multiply everything by g, you take it off. But then you see the answers, and they keep multiplying by g. Yeah.
They didn't bother. They perhaps didn't bother to put the g in because they were going to cancel it anyways.
No, because on the result,
like
it's multiplied by g. Like you see it.
Oh! They kept g in the answer.
Yeah.
Oh, they shouldn't really be doing that in this course. They should multiply it.
Like, let's say I got 2, but their answer was 4. So, they multiplied it by 1, not 4. But
yeah, whatever it is, yeah. Okay. Is there any examples you need me to do? Yeah? You have one. Okay, let's have a look at it. You have any question? Check it, yeah, check. Ah, she is? Yeah. No.
Yeah, and number 11, like they ask you, is it better to put the pillars of the bridge closer together, or?
Yeah.
The answer, I wasn't really convinced. Like,
what did they say in the answer?
That they actually asked it was better so that it could support more, like give more strength or force to it, but the answer was that it won't change the total amount of force that's needed to support the same.
Yeah, but what do you think personally? Should it be closer together or not?
I mean, the closer together, the more force it can stand, right? The bridge.
No, I don't think. Well, you see, okay.
The actual bridge, like it will have less weight. So
I don't know. No, for me, I would say it would be better to have the pillars a little bit closer. But I just wonder what the reason is. No, but guys, with that pillar question, I have my own reason. I'm just wondering what your reason might be if you move the pillars closer.
I would say that the closer you get them, the smaller is the bridge, so it can outstand more
yeah,
weight.
But why?
I feel like if
it's true, but why?
Because the bridge itself has less weight. So
no, the weight of the bridge hasn't changed, though.
I think that if let's say an object was here or in a different spot, the distance from this support would be shorter than if it was like this, and this side would be bigger here and this side would be bigger.
Yeah, so why is that a good thing?
Because it's close to the center of gravity.
But why? What? Like, I mean, okay.
No, because the torque or something is like distance, right?
Yeah.
Isn't it smaller than the force?
So there's two reasons. The torque would be better. Less torque. That's a good thing. Okay. The second thing is, by having the pillars closer together, then there's less of a sag in the middle of the bridge.
Oh yeah, the
sagging effect. Yeah. So for me, in the picture, you don't really want the pillars at the end. You kind of want the pillars moved in a little bit. So that there's less sag in the middle. Yeah. So I don't like that their answer said it shouldn't really matter. It kind of does matter a bit. But anyways, what will we do? Is there a question we need to do?
Yeah. So the advantage they say is that it reduces the stress at the bridge.
Can we do 11?
That sounds reasonable. Yeah. 11? Sure. You'll just need to read it to me. What is happening?
It's actually
Force up equals force down.
an engineer is designing a bridge.
Yeah.
But has to consider the forces acting when a lorry is driven across it as shown below.
Oh, is that the picture there?
Yeah.
Mm-hmm.
So if you just turn that around, I'll just draw it. So there's an S1, yeah, an S2. There's a lorry of 3 times 10 to the 5 newtons. And then there's the weight of the bridge, which is 2 times 10 to the 6 newtons. Okay, good. And what's the first question do they want? Oh, what's the size of the bridge? The length? Does it say?
It's designed to be 80 meters long.
Oh, yeah, okay.
80 meters, like that, yeah?
And we'll have a weight of 2 times
10 to the 6, good. Does it say where the lorry is?
Yeah, 15 meters from to the right of support 1.
15, like this?
Yes.
Yeah, okay, so what's the first question? Find...
The magnitude of the support forces, S1 and S2.
I'm going to take this as the turning point. So is this clockwise or anti-clockwise? What is it? It's clockwise. This one? Clockwise. This one? Anti. If this is the turning point. Yeah? So I can say 15 times 3 times 10 to the 5 plus 40 times 2 times 10 to the 6 should equal 80 S2. So if I divide by 80, I have my S2 already. So what's S2? If someone can type that in, please.
I have 1.057 by 10 to the 6.
Are you confident of that?
It's like I'm good on my results.
Can someone confirm him? Is the answer, I mean? It's right? Okay. So, to get S2, we can say S1 plus S2 equals 3 times 10 to the 5 plus 2 times 10 to the 6, yeah? So then that means S1 would be 3 times 10 to the 5 plus 2 times 10 to the 6 minus 1.057 times 10 to the 6. So what's that? So yeah, when you're ready, what's this one, please? Yeah?
Times to the 6. That's what I got.
Okay. Well, you were right the first time, so maybe you're right the second time. Is he right? Yeah, okay, what's the next question there? You got it? What's the next part asking you? You have it, Lynn.
No, it was the one that we were discussing.
Yeah, the one with.
Oh, it is suggested that moving the bridge support across together might reduce the forces S1 and S2. Discuss the effectiveness of idea. Is it correct, and are there any other advantage to moving them? Okay, so the first thing is, the first part of the question is, does it affect the forces on it? And the answer is no. S1 and S2 added together, that must equal the total downforce, which we said, what was it earlier? 3 times 10 to the 5 plus 2 times 10 to the 6. It'll have no effect on the force. However, for the second part, are there any advantages or disadvantages? So, although it doesn't change the force, there is an advantage and a disadvantage. So the advantage, we said, one advantage was less sag at the centre. Yeah? There'll be less of a sag if you move them together closer, which is good. Okay? But what about disadvantage? Is there a disadvantage to doing this? No, there must be some disadvantage.
No, like, did you ask?
I thought they said discuss advantages and disadvantages, no?
Discuss the effectiveness, is it correct? And are there any other advantages to moving them closer together?
Oh, nice. Let's forget about that, so.
Well, one would be disadvantage.
So, that's what I'm thinking about.
You can maybe like the bridge is somewhere like a river or something.
Yeah, I was just thinking that actually if the bridge is over a river, I don't know, it probably gets harder to put the pillar nearer to the centre, away from the bank. Don't know. Perhaps that's it. Yeah, I don't know. Right, what else? Is there anything else? No? What about the conservation of momentum? The change in momentum.
Well, we can't do 17.
Which one?
17 in.
17?
Which was, we could do B part B.
But what was A?
Angular velocity of the Earth in radians per second, centripetal acceleration.
Yeah, you're right, you can't do that. So what the heck was B that you could do?
A space rocket. Standing vertically for a launch.
Ah, that's okay. You could do the B part. Yeah. You can't do the A part until we do circular motion. That's fine. What number was that? 17? Okay. And 14 is a problem?
I don't know, I mean, my English showing this question is number 14.
Not 17? Oh yeah, on yours it says 14. Maybe it's 14. Oh yeah, there is no 17.
I think it's updated.
Maybe I updated it? I don't remember updating this. Did I?
Which one?
Anyways, it doesn't matter. It's ID 293. That never changes. I am going to move that question to the circular motion homework, but you already have half of it done. Is everything else okay in that lesson? Part C of question 9. Is that ID 253?
Question 9 and which one?
From the rate of change of moment.
Yeah.
High 4.
Yeah. What's the ID number?
ID number is.
The ID is beside the question.
Oh,
454.
4, 5, 4.
454. Where is 4?
Oh, that's question
454. Let's see. 454. 454. 454. Part C, is it?
Yeah.
Okay, good. Let's have a look. This is on the momentum homework. ID number 454. The ID never changes. That's the database number. Okay. Part A and B are okay? Yeah? So, a garden hose is used to some water. So here's my water. It's moving at 5 meters per second. And it's 1.2 kilograms per second. What the heck? This is my hose. The water comes out. And the first question is, what's the momentum? Well, that's easy. That's 6, isn't it? Kilogram meters per second. B, what's the force? Well, that's delta P over delta T, which is 6 over 1, which is 6 newtons. Easy peasy. C, if the water were to rebound from the wall, it would have a small velocity in the opposite direction. State and explain what effect this would have on the magnitude of the force of the wall. On the magnitude of the force on the wall. Okay. So what happens is the water hits the wall and then bounces off. So it says it bounces off with some small, speed. What letter will we give it? We'll give it some small letter. I'll just call it v. But it's minus v since it's to the left. Okay? So, what is the change in momentum? Well, first it was going 6. Yeah? No, this time it's not to 0 because it bounces backwards. So it's 6 minus 1.2 times minus v. Yeah? Is that okay? You don't look happy. Are you okay with this part, 6? Yeah, and is this okay? Are you sure? Yeah. Over 1, if it's per second. Okay? Oh, sorry, not over 1. And then what I'll do is I'll divide by delta t. What is delta t? That's 1. So this will be 6 plus 1.2 v. So this here, what's this? This is F. So F equals 6 newtons plus 1.2 v newtons. So in other words, the effect is to make the force greater. Okay? So if the water hits the wall and stops and just kind of falls down, or if the water hits the wall and bounces back, in the second picture, that's actually more force. If the water just stopped, it's less force because the v will be 0. Okay, so it causes 1.2 v more force on the wall. But because of Newton's third law, you could say it the other way around. Or the other way you can give the answer is, or the wall exerts 1.2 v more force onto the water. You know Newton's third law, it's whatever direction. Yeah? They probably said something similar in the answer, did they?
So 1 times 1 times 1.
Yeah, because for these momentum questions, often you look at what happens per second, over 1 second. Yeah, well, I wonder what they say in the answer. I'm hoping they say something like, there is more force. Huh?
Force is greater because change in momentum of water per second is greater.
Yeah. Not only, I actually specified how much greater, 1.2 v, but it looks like they don't care about that. It was enough just to say it is more. But I actually said how much more. Yeah, is that okay? Yeah? Shall we continue, or is there any more questions? No, we're okay? We'll continue? Alright, let's see what lesson is coming up next.